Okay, we're going to go ahead and go over chapter 6, which is area of two curves. Okay, so to start off, let's go ahead and draw something. So if we have two curves, such as this, what we actually mean when we're trying to find the area of two curves, we're looking for here, this. Basically, wherever these two curves intersect. So if we were to draw this out, we have this and this. And this is the area that we're looking for when we're asked to find the area between the two curves. So the best way to kind of look at this is if we look at an example. So the first thing that we have to do is we have to make sure that these functions are continuous. If they're continuous functions and one is greater than the other, then the area between the two functions, which is on an interval of a and b, is a to b of one function, which is the top function, minus the second function, or the bottom function. And with respect to whatever you're looking at it from. Okay, so let's look at it in the form of an example. So, example number 1. Find the area bounded by the graphs of the functions y equals x squared minus 4x and y equals 2x. So, if we were to actually draw these out, well, we know that y equals 2x is a line, right? Y-intercepts in b0, and our slope is 2. So we rise 2, we run 1, and this is our line, right? And, well, we know what y equals x squared minus 4x looks like. Well, it looks like a parabola. So we know that it's going to look something along like this. But where exactly is it going to be? Well, what we can do is we can go ahead and when we set them equal to each other, we can find out where those two graphs will intersect, or those two functions intersect. If we set it equal to 0, or we set our x's equal to 0, then we know what our y is. So if we set x equals to 0, we know that y is going to be 0 at some point. So we know that it's going to intersect here at some point, right? But if we set them equal to each other, we can find out where both of these intersect. So x squared minus 4x is equal to 2x. So what we can do first is we're going to go ahead and subtract 2x from both sides. These cancel out. We're left with 0 there. And we're going to have x squared minus 6x. Okay? We can pull out an x, and we're left with x minus 6 inside the parentheses. And our 2 points where these two graphs are the same is x equals 0 and x equals 6. Okay? So, that means that here and here is where our two functions intersect. So we know that this is a parabola, right? And we know that this is a line. At some point, they're going to intersect at when x is 0 and when x is 6. So what's the question actually asking though? It's asking us to find the area bounded by the graph of the function y equals x squared minus 4x and y equals x2. So that means we're looking for this, the area between them. And the way we can do that is the form of an integral, which is the area is equal to the integral from a to b of the top function minus the bottom function. And in this case, it's with respect to x. So we know that we're looking at the x-axis, and we're looking through from a to b, which are a in this case is going to be 0, and our b is going to be 6. So if we rewrite this, our area is equal to the integral from a, which is 0, and our b, which is 6. And our top function in this case is this one, which is y equals 2x. We don't need to write the y in there because y is basically another way to write f of x. So our function is 2x. So we have 2x, which is the top function, minus the bottom function, which is x squared minus 4x with respect to x. So what we have now is the area, which is equal to the integral of 6 of 2x minus x squared plus 4x dx. So what that actually gives us is the area between 0 and 6 of negative x squared plus 6x dx. And we know that our interval that we're looking at is between 0 and 6. And that's where we got these values here. So now what we need to do is we need to go ahead and use the formula of f of b minus f of a. And to use that, we can only use that when we've taken the antiderivative of the integral. And the way we take the antiderivative of it is we go ahead and negative x cubed over 3 plus 6x squared over 2, right? So now what we're going to do is we can go ahead and simplify these two, which is 1, this is 3. And we're looking at it between 0 and 6. And this is our area. So what we can do now is we have our area, and we have to use it in the form of f of b minus f of a. Or unless your calculator has a integration button, then you can go ahead and just plug it into the calculator and you can get your answer. But if you're actually told to show your work, then this is how you'll have to do it. So we know that this is our a, and we know that this is our b. So we plug this into our function, which is this. We're going to get negative 1/3. Our x, in this case, if we plug in our b, it's going to be 6 cubed plus, we're left with 3, 6 squared, and this is our f of b, minus our f of a, which is, if we plug in 0 into 0 cubed, we're going to get 0, over 3 is 0, plus 3 times 0 squared is still 0, so negative 0 plus 0 is still going to be 0. So what we're going to be left with is our area is equal to 108 minus 72 minus 0. 108 comes from this value, 72 comes from this value, and our 0 just comes down. So if we add these all up, we know that we're going to get, sorry, that was 108. We know that our area is going to equal to 36. Now that means that the area between these two functions is 36. Right? So let's go ahead and go over another example. So from here, we're going to move on to example number 2, which is finding the area between 3 functions. Okay. So if we find the area, bounded by the graph of y equals square root of x minus 1, y equals negative x plus 7, and the x-axis, which we know is also y equals 0. So what we have to do is we have to set them equal to each other. Okay. So if we set them equal to each other, and if you square both sides of the equation, we need to check our answers. Anytime you're squaring, you have the possibility of eliminating a negative. And if you eliminate a negative, you can't just so easily bring that negative back. So if we set our y equals square root of x minus 1 and our y equals negative x plus 7 equal to each other, we're going to be left with negative x plus 7 equals square root of x minus 1. And like I said, if we square it, we're going to lose some negatives. So we're going to be left with this x minus 1 equals x squared minus 14x plus 49. So what we're going to be left with here is if we go ahead and add 1 and subtract an x, these and these cancel out, left with 0. If we subtract an x and we add in 1, we're going to go ahead and be left with x squared minus 15x plus 50. If we're able to factor these out, great. If not, we're going to have to use the quadratic formula. In this case, it's actually factorable. So we have x minus 5 and x minus 10 equal to 0. So we know that these two are supposed to cross at x equals 5 and x equals 10. But since we squared them, we have to go ahead and check if they fit into our answer. So if we choose x equals 5, we have to go ahead and see if it's true. And we have to plug x equals 5 into both equations. So y equals square root of 5 minus 1, which is y equals square root of 4, y equals 2. And it happens to work. If we plug it into y equals negative 5 plus 7, y equals 2. So they both equal each other. Now, if we plug in 10, so we use 10 to plug it into our y equals square root of 10 minus 1, y equals square root of 9, y equals 3. And if we plug it into our other equation, y equals negative 10 plus 7, y equals negative 3. As you can see, they don't match. So this one does not work. So now, if we actually draw out our graph, and our graph was y equals x minus 1, we know we're going to start at 1, and this would be something along like this. And if we draw our line, which was y equals negative x plus 7, we know that it has a y-intercept of 7, and it has a slope of negative 1, 1. So our line is going to be something like this. And we know our last line is with the x-axis, which is y equals 0, which is here. So what the question is asking for us is to find this area. But as you can see, when the answer that we got when it was x equals 5 and x equals 10 when they intersect, you can see it intersects here. But as you can see, these two functions, this one and this one, don't intersect anywhere else. Over here would have been 10. Here is 5. As you can see, they don't intersect there. So that's why we needed to check, especially when we're squaring, to make sure that those two functions intersect at the right places. So now we have this diagram, or this graph. What we're going to have to do is we're going to go ahead and have to figure out, we're going to have to cut this in half, and we're going to have to use two integrals. And when you have two integrals, all you have to do is take the integral of the left side plus the integral of the right side, and you add them. Okay? So what we're going to do is we're going to look at the left side only. Now, the function that we have on the left side is basically our square root of x minus 1 and our x-axis, or y equals 0. Those are the two functions that we have on the left side. So our first integral is going to be from a to b of our top function on the left side, which is our square root of x minus 1, minus our x-axis, which is y equals 0 minus 0 dx, plus our second integral, which is going to be the right side of that line, or that dotted line. And if we look at it and we see what we have on that side, all that is just our line with the x-axis. So what's our top function for that one is going to be negative x plus 7 minus 0, which is the x-axis with respect to x of our a and b there. So what we're looking for in our first integral for the a is where they start and where it ends. So we know it's starting at 1. So we know that our area is equal to our first integral, which is starting at 1, and we know that it ends here at 5. Right? So it's going to be the square root of x minus 1 dx. Plus, our second integral, we know that it starts at 5, because that's where the first one finished. But we need to know what this point of intersection is. So if we set these two functions equal to each other, which is y equals 0 and y equals, what was that function? Negative x plus 7. If we set them equal to each other, we'll be able to find out what is this point of intersection there. So 0 equals negative x plus 7. So that way we know that that point of intersection on that x-axis is when x equals 7. So this is 7. So we know that the right side of that graph, or that graph, it ends at when x is 7. And our function is negative x plus 7 minus 0, which we don't need to include, dx. So what we need to go ahead and do is just go ahead and take the antiderivative of those, and we should be good. So if we take the antiderivative of this, we can go ahead and substitute x minus 1 with the u substitution. So if we were to go ahead and just do a u substitution, u is an equal x minus 1. What we're going to have here is we're going to have an interval between 1 and 5, square root of u. If we take the derivative of u equals x minus 1, we're going to have du equals the derivative of x minus 1 is to be left with 1 dx. So du and dx actually equal each other. So we can go ahead and rewrite this as 1 to the 5th of u to the 1/2. And if we take the antiderivative of that with respect to du, we're going to have 2/3 x minus 1, so we're going to plug u back in, 3/2. And we're going to look at it between 1 and 5. Plus, if we take the antiderivative of this, or negative 1 plus 7, what we're going to get is we're going to get negative x squared over 2 plus 7x. And this antiderivative, we're going to look at it between 5 and 7. Now, if we go ahead and just plug our f of b minus f of a into both, each one individually, we're going to get our 2/3 of 5 minus 1, 3/2, minus 2/3, 1 minus 1 of 3/2. And if we apply our f of b minus f of a into the second part of it, it's going to be plus negative 7 squared over 2 plus 7 times 7. And then what we're going to have is minus negative x squared over 2. Actually, we're going to plug in 5 for the x plus 7 times 5. And if we go ahead and solve this, what we're left with on the left side is 16/3 plus 2, which gives us 22/3. So that's how you can go ahead and solve the area between 2 curves, 3 curves. I mean, sometimes you can even do 4 curves. It all just depends on how you want to look at it. Sometimes you might be able to go ahead and manipulate it, and you'll be able to look at it in the Wise perspective, which we can go ahead and talk about next time.